4.1, we're talking about area of parallelograms. Remember that a parallelogram can be turned into a rectangle. That's what we worked on in class with the cutouts. So the formula for area of a parallelogram is going to be very, very similar to the formula for area of a rectangle, which you guys all know really well. The one big difference between the formulas when we start talking about parallelograms versus rectangles is that because there's no really good way to tell length and width on a parallelogram, we start using these words, base and height. And remember that the base is just going to be one of the sides, usually one that doesn't have the cut angle like that would be considered a base. And then you'll be able to tell the height because it's going to make that 90-degree angle. Remember, it's going to be perpendicular from one side directly across to the other side, and it's going to make that 90-degree angle when it does that. So this would be considered your height, and it's going to be fine on a shape like this, but remember when it's turned sideways or something like this, it's going to be a little bit harder to picture a height. So again, you might want to consider just drawing it in first. Pick a corner and then make sure that it can go directly across to the other corner and make that 90-degree angle, and so that one would be considered your height, and that would mean one of the bases would be either of the sides that height was connected to. So then this would be your base in this case because it's the one that the height is coming from. So that's the only time it's a little tricky is when you're looking at it when it's sideways, because we're used to height going up and down, but this wouldn't be considered the height because it doesn't make that 90-degree angle to either one of these. It only makes the 90-degree angle, not very well in my picture, but it would make a 90-degree angle going across to the other corner here. So when we write the formula for area of a parallelogram, it's going to be base times height, and usually we just shorten that to capital A for area is equal to B times H. You can choose to put the dot in between, or you can just put the B and the H together to mean multiplication. When we do start substituting to try to solve for the area, obviously you're going to either have to have the dot or some parentheses in there. For example 1, we're going to just go ahead and find the area of this parallelogram. So first we have to make sure we understand which is the base and which is the height. And again, we can figure out the height goes from one corner straight across and makes that 90-degree angle. So it's pretty easy to tell now that this one is our height. And then that would have to make one of these. Doesn't really matter which one because they're going to be equal. And this one is the one that has a number on it. But so one of those would be considered our base. And then we'll just use the formula. Capital A for area is equal to base times height, and then we're going to fill in with our numbers. So our base here was 12 meters and our height was 14 meters, and you'll notice I'm not putting the label in there right now. We'll do that at the end. And then do your side math, calculate 12 times 14. In this case it ends up being 168. And then you need to give a final answer, which does include a label. And since it's meters times meters, it would be the same thing as meters squared. And remember, all area is going to be square units anyway, just like it was with rectangles. It will be for any polygons. Area will always be units squared. And for letter B, we've got a different parallelogram, but again, you can see this one's turned sideways, so we're going to determine the base and the height, and again, we're going to notice one of these goes from one corner straight across to the opposite and has that 90-degree angle, so that means this one actually has to be the height, and then the base would have to be one of these, and again, they're equal, so it doesn't matter, but this one has the actual measurement right next to it as the base, so that would be our base, that would be our height this time. And again, we're going to use this, and maybe you heard me say it on the last example we did, but we're going to do formula first, always, so we write the blank formula. Then we do the step that I call fill in, which is where we substitute our numbers that we do know. So in this case, we're going to fill in with the base being 8.5 feet and the height being 4 feet. And then we go to final. In this case, it's going to take more than one step to get to final, though, because we're not just multiplying whole numbers. We do have fractions and mixed numbers involved. So now you have to remember to turn your mixed number into an improper fraction, do any steps to multiply correctly, and then you'll be able to get your final answer. So when we turn 8.5 into an improper fraction by multiplying the denominator by that whole number and then adding the numerator, we get 17 over 2, and then we multiply that by 4 over 1 because that's 4 as an improper fraction. We still look to see if we can cross simplify, which when I look this direction, I can't go any lower because 1 is already prime, so is 17. But when I look at this one, 2 and 4, I know they have a common factor of 2, so I can divide them both by 2 and get a little bit lower. And when I do that, this is going to become a 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. So I'm still going to take advantage of that rewrite step just to make sure that I don't accidentally miss anything or mix it up. And then 17 times 2 would be 34 over 1, which you can write it as 34 over 1, or you can go ahead and just skip to 34. But what you can't skip is your label, so don't forget to check. In this case, it's feet instead of meters this time. And it would be square feet or feet squared as your final answer. When you're doing your on your own problems, the only one you're going to really want to kind of pay attention to as being a tiny bit different is this one, because you might notice that the height isn't actually inside, but you're going to come across more and more examples like this. When the parallelogram goes on an angle, it's a little bit hard sometimes to make that cut like what we did, so you could do it inside, but sometimes there's just not enough space. Like we could make this exact same line in here and it would work, but so sometimes when they run out of space or they think it makes it look a little bit more organized, you'll sometimes see that height line outside of the shape. So it doesn't mean they've made the shape any bigger or different. They just draw a line which would technically be parallel to something that they could do inside like that. They would be exactly the same distance and all of that stuff, and they just sometimes put it on the outside. So it still means this is the height and this is the base because it makes that 90-degree angle, but it will be something you'll see more commonly as you get into this geometry stuff. In example 2, we're going to practice finding the area of a parallelogram on a grid. You do not have to copy all of the lines on the grid necessarily. You can just kind of listen along on this part and then write in the next piece here. And so for this one, when we're going to try to find the area of a parallelogram on a grid, you can see we could start counting boxes, but then it gets a little tricky because then you've got some boxes that have some of it colored in but not all of it, and it would be a little bit hard to figure out exactly what the area would be if we wanted to count the amount of space it takes up inside, which is what area means. So instead we're going to count grid lines, and we're going to do that for the base and the height. So again, we have to figure out what's going to be what here, and in this case it looks like the only way to get a complete perpendicular line would be that we're going to have to drop outside of our shape a little bit here, because nothing that I come through for a corner goes straight across and makes that 90-degree angle, because here I come straight across, but see, it's not a 90-degree angle, and here I come straight across, but it's not a 90-degree angle. Here, if I were to drop down a line from this corner down, I can make a 90-degree angle because it will make a perfect 90-degree square there. And so even though it's on the outside of the shape, this could still be used to help me find the height, because it's going to be the exact same distance as it would be from inside, and so we can still count that as the height. And then if this is the height, which is going this direction, then that means one of these, and it doesn't matter which one, would have to be our base. So we call either one of those our base. And then we just go ahead and actually count boxes to see what is what. So starting with the easy one, the base, you can see we have one line across and two lines across that make up our actual shape. So that means the base is 2 units. There's no actual measurement of like feet or inches, so we would just call that 2 units. And we don't measure any of this part because this isn't actually part of our original shape. But then when we go to determine the height, we're just trying to figure out what the actual distance from the top to the bottom would be. So we can still count on this one. And so we have 1 box, 2, 3, 4, 5 boxes, which means that our height would be 5 units. So for this part, you could just draw a little parallelogram that looked kind of similar to that one and put it, mine ends up looking like a rectangle, you can see that, but just kind of put it in there, and then you can fill in your base and your height. And a lot of times you'll start to do this, you'll start to kind of just kind of sketch in your height line, which would be 5, and then you can use your formula, which is still area equals base times height. You can fill it in with the base being 2 and the height being 5, and 2 times 5 is 10. And again, because they didn't tell us what the unit is, we just call it units squared or square units. For this on your own, again, you don't have to draw all the grid lines or anything like that. You can just draw something that would look like this parallelogram, and then you would use your grid lines to count and figure out what your base and your height would be equal to, and label those, and then fill them into your formula and come up with your final area. Here's the answer to your on your own, and I just went ahead and drew into the original one, but again, you could draw that and label it. So there were 4 boxes or grids across the bottom, 1, 2, 3, 4 for my base, and then if I just kind of drew my height line out there to make it that 90-degree angle, then there were 1, 2, 3 boxes worth of the height. So 4 times 3 is 12 units squared. And just a quick reminder, when you are dealing with square units, you don't want to put the squared sign there because that would mean 12 to the second power, and we don't want to do that because that's equal to 144. We want it to be over here because it's the units that are squared, because it's units times units. So that's where we need the squared, not on the outside of the number.